So, of course, I want to start by saying thank you, everyone, for joining. My name is Cody Armstrong, and today we're discussing top-down design, but using multi-part part studios to accomplish it. So, we're going to discuss top-down design, but in the context of multi-part part studios and not so much in context assembly design. So, for those familiar with our top-down design techniques, we have two different techniques for designing top-down, and we're going to focus on the multi-part aspects of it. I also want to spend some time today discussing the way this has been done in older CAD systems. And I think there are a lot of users out there that veer away from top-down design in a multi-part environment in Onshape because of the multi-bodied nature of past CAD systems. So I want to go over some of those details as well, discuss the way, what we have in Onshape multi-part part studios compares to multi-body systems of SolidWorks and things like that. So designing top-down with multi-part part studios. Now, as I always say with these webinars, we really encourage you to ask any questions that you would like. There's a questions section of the GoToWebinar control panel. Feel free to ask any question that you'd like, and I'll do my best to stop and answer the questions as we go through things. So let's dig into it. Now, the agenda today is pretty straightforward. We're going to start with a simple introduction into multi-part design. So what do I mean by multi-part design? But then I want to get into how multi-part design differs in Onshape. So if you've done multi-body work in the past in other CAD systems, I want to discuss just briefly some of the differences between what we've done in multi-part and multi-body approach. And I do want to walk through a few examples of multi-part modeling and really where I think some of its biggest benefits are. And of course, we're going to walk through some of Onshape's advantages in multi-part design. But as I mentioned before, feel free to ask any question that you'd like in that question section, the GoToWebinar control panel. I'll do my best to answer the questions as we go through things here. So that is a brief agenda. Let's get started. So I want to start with a simple introduction into multi-part design. What do I mean by multi-part design? And to put it simply, of course, it means designing multiple parts together, right, in the same environment. And it's a form of top-down design. And I think if we were to ask the users what do they think of when they think of multi-part design, it's different than in context in the sense that it's done in the part modeling environment in most old CAD systems. So when you think of multi-body modeling, it's in the part environment, right? Not in the assembly. So multi-part traditionally differs from in context in the sense that it's done in the part studio environment or in the part environment in old CAD systems. But it is a form of top-down design. You're essentially designing multiple parts in the same space, and you're doing that for the benefit of the relationships that are easily created between them. The alternative to this approach is what's often referred to as a bottom-up modeling, where you model each part independently in its own tab, right, or in an old CAD system, its own file. So bottom-up, top-down design, two different philosophies, but within top-down design, you've always kind of had these two approaches, right? Multi-body and in context in old CAD systems, or an Onshape multi-part and in context. And we're going to stick with just that part environment for the sake of this webinar. So that's a simple introduction into designing, multiple parts in a single part. And that's the term for it. And in old CAD systems, what you had was what's often referred to as a multi-body approach. So you can create multiple solid bodies within a single part. And that's the common workflow in something like SolidWorks, for instance. So in the screenshot on the left, you can see there's a concrete bucket designed in a single part in SolidWorks. And you can see it has, forgive me, it's a bit small, but there is 41 solid bodies within this one part file, right, in SolidWorks. And this has always been the approach of, these older CAD systems, is to have that, bodies as opposed to parts. But if you think of this concrete bucket, yes, it's helpful to design it all together, right, in this part, but those are real parts, each with their own part numbers, descriptions. They need to be treated independently like parts. And that's where, older CAD systems fall flat. When you try to insert into the assembly, maybe you need to insert nuts and bolts into your, concrete bucket in our example. Well, I need to take all of those bodies and insert them into the assembly to accomplish that. You can't do that directly. Right? So you have to take the bodies, export them out individually as files. So essentially what you have is a single, multi-bodied file that's then, split up into multiple part files. And then take all those part files are then inserted into the assembly. So there's this step between, the actual part and inserting into the assembly. You must take all of those bodies and save them off as separate files. And this process leads to a lot of confusion. It's a tedious workflow. It generates a lot of files in many situations. The screenshot that you see there is a 41 solid body part that in order to insert in the assembly, I have to generate 41 part files and then insert those into the assembly. So it's, somewhat of a tedious process, something that, arguably you could, say is one of the, biggest downsides to multi-body modeling, right? The need to export everything before you can insert it into the assembly. So that's one of the biggest things that I would stress about multi-body design and, these similar approaches in old CAD systems. And as I mentioned before, this creates kind of this web of files that really is troublesome to deal with, and it makes, things like updates confusing. So if you look at the workflow for old CAD systems, you had one file that was multiple bodies. Before you could insert the assembly, you had to export all of those bodies out as individual part files. This example only had 5 bodies, but our concrete bucket had 41, so you would see 41 part files here. Then all of those part files must be inserted into the assembly. So the reason I bring this graphic up to show this is the biggest question that often gets asked is, where do I go to make a change? It may be easy to export all of these parts and then insert all of these parts in the assembly, but where do I go to the change? Do I go back to the original multi-body file, export everything again? Do I go to these intermediate part files that were generated as part of the process of going to the assembly? Do I edit those? This becomes a cumbersome workflow, especially when you start incorporating things like data management solutions into it. It just generates a lot of noise, a lot of mess, right? And this is the workflow that a lot of users are familiar with today. So multiple bodies and inserting those multiple bodies into the assembly has this middle step, this intermediate step that every user must deal with, and it tends to generate a lot of files. So that's just a short recap of the approach of multi-body and its disadvantages, the reasons that we went with a different approach in Onshape. And what I'd like to discuss next is what's different about Onshape. And in our scenario, the thing that I would stress is in a part studio in Onshape, you can design multiple parts together in the same part studio. But these are real parts. And the distinction is they have the ability to be inserted directly into the assembly individually or all together. There's no in-between steps for them. They can have part number, revision, description, all the things you would assign to a part if it was modeled alone by itself. You can assign to a part that was built in a part studio with a bunch of other parts. So in terms of metadata, in terms of inserting into the assembly, inserting into the drawing, there's really no reason not to design, in a multi-part scenario if there's, a benefit to it, if designing top-down is a benefit to you. So again, from the beginning in Onshape, when you design multi-part, you're designing real parts. So you can, feel free to know that there's no export out as this, and then you can insert into the assembly step. You can go straight from a multi-part part studio into the assembly with no in-between steps needed. And as I mentioned before, there's no difference in terms of metadata or how the model is interacted with when we regards to whether it's modeled in a bottom-up manner in a single tab or a top-down manner in a multi-part part studio. So that's the key thing that I would stress, and it sounds like a simple thing, but it really opens up the workflow for multi-part part modeling. If you think about multi-body design, the fact that you had to then generate all these files and then insert all these files into the assembly really hampered the update workflow and making design changes. What happens to all those files? Do they get regenerated and so on? So it always meant it was a cumbersome approach. Whereas in Onshape, you can make these design changes in the Part Studio. They instantly update in the assembly, and there's no in-between step that causes an issue. So to reiterate, the workflow when we talk about Onshape and inserting multiple parts into the assembly, a single step, right? Literally one click, from the insert, you can insert the entire Part Studio or any piece of the part, any part within that Part Studio. So far simpler workflow. Again, a lot less noise that's being created when you want to work in a top-down manner, but in a Part Studio environment. And that's, by the way, why we call it a Part Studio and not just a part. Because in Onshape, you can design multiple parts in that environment. And so we refer to it as a Part Studio just to distinguish the fact that it's not just a part. It can be many parts if you want to. So that's a simple explanation as to the differences between past CAD systems, the multi-body CAD systems of the past, and multi-part part studios. So let's jump into an example. As I mentioned before, feel free to ask any questions that you'd like. There's a questions section there in the GoToWebinar control panel. I'm going to walk you through a few simple examples of multi-part part modeling just to get you started, and we will wrap things up. So now this example that I want to start with is kind of the quintessential example of multi-part part modeling, where you have these related parts that benefit from being designed together. Right? And that's really what top-down design is all about. It's really about designing parts that have good, easy to model relationships with one another that would be difficult otherwise. And a great example of this is a cantilever clamp. So I'm going to jump into an assembly here just to show you what the finished thing looks like. And if you look at this cantilever clamp, we have two arms that have relationships to one another. We have all these pins that are pressed in at different locations. So this is an excellent example of something that benefits from being modeled top-down, where I model everything kind of in that same space. Now you can see, if I jump to the Part Studio tab, that all of the parts in this cantilever clamp were modeled in a single Part Studio. In this case, you can see 10 parts in this Part Studio. That's an excellent example of top-down design in a Part Studio environment, right? In this example, I have one sketch that essentially drives 10 parts. And if I change this one sketch, the locations of the pins and the ends and all of these things will shift at once. So I often get asked the question, do you have the kind of master sketch technique, master model technique? And the answer is yes. And this is an excellent example of doing that, where I'm using a sketch to drive a number of different parts. But that aside, again, this is an excellent example of something that I would design in a Part Studio. These parts are related. And they have the benefit of being very easy to design together, right? If I had to design this part, for instance, in its own Part Studio, I would be constantly going back and forth, taking measurements between things, when I can just as easily design it in the Part Studio, with the arm and its other components. So that's a simple explanation and an example of the cantilever clamp. But how do we get here? How do we create multiple parts in the Part Studio? And what I'd like to do is walk you through an example from scratch. So here, all we have is a sketch and a plane. And I just wanted to go to that point so that we can start creating features and walk through creating some of these parts. Now, I'm going to use this one sketch to create multiple arms, 2 arms for our cantilever clamp in this example. We're also going to use that sketch to drive other sketches. As I mentioned before, kind of using this master sketch technique to control the entire design. But it starts with a simple extrude. So I'll click the extrude command, and we'll say we want a 3mm depth, and then I could define what it is that I want to extrude. Now, if you've been using Onshape a while, you'll know you can just click the sketch from the feature list. However, in our scenario, I wouldn't want that behavior, because remember, when you select the entire sketch from the feature list, it grabs the entire sketch. In reality, these are two independent extrude features. So I will need to go in and select the contours that I want to extrude, right? So now I've selected the contours associated with that first arm of my cantilever clamp, right? I can hit the green check OK, and now I have the first arm done, right? You can see part 1 here. I can right click, rename it. We can call this the large arm, right? So now we have our first part done. The question then becomes, well, how do we use the sketch to create a second arm? And I can go right back to the extrude command and then start clicking on more contours within that sketch. And this is a technique that is, if you're used to older CAD systems where it's one sketch, one feature, one sketch, one feature, this is a bit of a break from that. But it is a powerful technique, right? Because I'm reusing this sketch multiple times to create, in this case, two independent arms, right? So I can come in and just start selecting. In this case, we want 3, right? And I could just start selecting the contours that make up, in this case, the second arm. Now, what I want to point out about this is, by default, when you do this, when I go to extrude, for instance, and I start selecting contours, if the feature can merge with another part, it will. So you can see in this example, I've chosen extrude, I've selected those contours. It assumes that I want to merge this extrude that I'm creating right now with the extrude we created just a moment ago. But I don't. Right? In this example, I want a separate part. And that's an important distinction. That's part of the most important thing when we talk about multi-part part modeling, is defining, no, this is a separate part. And you do that by choosing new in the feature. So it doesn't matter whether it's extrude, revolve, sweep, loft, any of those features, a number of features in the toolbars, you have the option for new, and that will give you a new part in the part studio. You can see I have part 2 in this part studio, right? So these Boolean options across the top, the new option is kind of the key to multi-part part modeling, right? Every time you want to create a new part, just create that feature and define it as new. I hit the green check OK, and now I have 2 arms for my cantilever clamp. And again, both arms are driven from this one main sketch. Question: could you review the benefits of multi-body / part versus just in-context modeling, assembly modeling? Great question. So in general, the benefits of in-context versus multi-body. What I would say with regards to Onshape specifically is, multi-body has its limitations when we start talking about a large number of parts. I really wouldn't want dozens or hundreds of parts in a single part studio for performance reasons, for modeling reasons. That's where in context and the assembly, more importantly, have their benefits. So large number of parts, a lot of positioning of parts, where you have to put parts in certain positions that are very specific. Moving parts around in a part studio is not a fun process. It's transforms, it's establishing custom made connectors and so on. So it's much easier to move parts around in the assembly and just design in context. But in our cantilever clamp, everything designed from the ground up. I have these 9 or 10 parts that are related to each other. They're all designed in this one scenario, this one space. That's where multi-part has its benefits. I would really get into in-context assemblies, and I would say this is for old CAD systems as well, for bigger things. More and more parts where the performance of a single part environment just really lags. All right, so when I need to create multiple copies of a part, do I do it using the pattern feature? Should I sketch in the window or in 3D? Also, every time I get multiple parts, is there a way to group them? Okay, so questions about multiple parts. This is a good time to bring this up, so I'm going to use this kind of a segue here. What you'll notice about multi-part part modeling, I'm going to jump to a finished example just to stress it again, is you'll notice that I only have modeled one of each part, right? But if we look at the assembly of a cantilever clamp, of course, has two arms, right? An arm on either end. But I did not model two arms in the Part Studio. And there's a reason for that. In the Part Studio, there's no recognition for independent instances of the same part. When you think of this cantilever clamp, what I would expect to see in my bill of materials is this arm, quantity 2, right? 2 instances of the same arm. That's why we did not mirror this in the Part Studio. So I would stress this again. I mentioned this earlier, but you do not want to do things like pattern or mirror parts just to insert multiple instances of them in the Part Studio. That's, in general, not the best technique. If you have to work around a lot of instances of the same part, that's an example where you'd want to use in-context assembly, not multi-part. I hope that makes sense. But I think the simple rule to follow is in a Part Studio, you never want the same part twice. Right? The same exact part number should never be in the Part Studio twice. That's the general rule I would follow. If you have to design around multiple instances of the same part, really should create an assembly. The reason this is critical is primarily the bill of materials. If you generate a bill of materials, if I mirrored these arms of the Part Studio, it's viewed as two separate parts with two separate part numbers and so on. And of course, that's not what you would want, in the bill of materials if they were in fact the same. So a bit of an aside, but it is something that I want to stress. It's something that kind of distinguishes the two workflows. You really want to focus on in context if you're doing that kind of work. So I hope I made that clear. Forgive me if it doesn't. But all right. So jumping back to our example, I've now modeled two independent parts. Right, these are two parts that are treated no differently than if I had modeled them in their own tabs. Right, but I get the benefit of them being both driven from the same sketch. So I can edit the main sketch and both arms would update. I can even design more features around these sketches. So for instance, the pins that you see in the example, right? We could easily design those pins in the Part Studio, right? I can easily start, let's say, a sketch on the top face and do things like convert edges, right, or offset edges. Or, sketch circles. My key point that I would stress here is even this new sketch that I'm creating is still tied to the first sketch that we created, right? Notice that the first sketch is showing. I have it set to show, and that all of the sketch geometry that I'm creating now is referencing that original sketch, and that's what gives me that ability to control everything from this first sketch. So now I've created a second sketch in this scenario, and we can create another. So let's create another sketch here, and we're going to do something very similar. Let's grab these and convert the edges here. We want that, and we want that. Right. All right, so now we've sketched 4 circles in 2 different sketches, but all of them are tied or constrained to that first sketch. Right, so this is what's often referred to as a master sketch or a master model technique, but it allows me to control everything from that first sketch. And now I can take this and extrude it. And one of the unique things that I would stress that, again, is a bit different than older CAD systems is you don't have to worry as much about that one sketch, one feature, one sketch, one feature, one sketch, one feature workflow. Here I've created 2 sketches, for the pins, and I can extrude both of them at the same time. So I can click both sketches, click extrude, and now I'm extruding all 4 pins, in this one sketch, right? So we can flip things around here. We'll extrude up to face and use our plane. And so now I've extruded 4 more parts. Right? Remember, each one of these pins is a new part in the Part Studio. I can hit the green check, and now I have 4 new parts listed in my parts list. Right? So, again, you really don't have to follow the workflow of one sketch, one feature. You can have one sketch drive many features. You can have multiple sketches drive a single feature. It's really up to you, and it really allows you to do whatever best reflects your design intent, at that time. So I really want all 4 pins to be designed and controlled with a single sketch, single feature, and I can do that. Right. Now, another cool thing that you can do is you can do the normal, multi-body workflows when we talk about Boolean subtracts and things like that. One of the biggest reasons to do multi-body work in old CAD systems is the ability to subtract one body from another, to merge one body from another. It's a more advanced modeling technique that allows you to manipulate parts with other parts. And it is still possible, even in Onshape, to do that kind of what's commonly referred to as multi-body work, but in Onshape, it's just multi-part work, right? So we have the Boolean command in Onshape, and I could do union, subtract, and intersect. And the question comes up, how would I subtract one part from another? Well, I can do subtract, define my tools, in this case, these 2 arms, and then define the targets, or the things that will be subtracted from, as the pins. And what you'll notice is it will subtract the arm from the pin, giving me that perfect offset, right, between the 2. So here you can see as I select those parts, now I'm cutting the pins all to match the arms with a simple Boolean. I'm subtracting one from the other, and that's one of the benefits of working this way. If I had modeled each pin in its own independent tab, I would need to take a lot of measurements. I would need to figure out what's this whole value, go back to the other tab, type in that value to the dimension. What's the depth of this shoulder, go back, figure out that value, and so on. So it's, again, a bit of an advanced technique. This is not what users often do on day one, but once you adopt this kind of workflow, it definitely has a lot of power. Now, one tip that I have for this kind of workflow, especially in our scenario, is when you do Boolean subtracts, like in our example, it assumes that you want to delete the parts, remove the parts, but you can check keep tools, and in this case, that will keep our 2 arms. Now, in this case, we can hide the 2 arms, and you can see those cuts cut into the pins, right? So again, that's just the ability to subtract one part from another, and you only really get that benefit by designing them together in the same part studio. Now, I mentioned before, these are real parts, and the distinction isn't. I haven't really pointed out why that's important just yet, but I want to get to that point. So let's say, for instance, that we've designed all these various parts, in this part studio, and we're ready to take that and assemble it. As I mentioned before, we want to assemble everything, insert maybe some nuts and bolts or things like that, and we're ready to bring this to a close. Generally assemblies and then the drawings are kind of the final steps once you finish that design. But if I had designed this in an old CAD system where these were independent bodies, say for instance these were independent bodies in an old CAD system, I would have to export each one of these parts. In this case, I have 10 parts in this clamp. I would have to export them individually as files before I could insert them into the assembly. Now, if you work a lot with files, if you've ever worked a lot with files, you'll know that working with and managing, in this scenario, a small part studio, 10 more files is troublesome. But the question that often comes up in that kind of workflow is, you have a multi-body file. It generates a whole bunch of part files for each body, right? And then you add all of those part files into an assembly. Where do you go to make your change? Do you go back to the original multi-body file, make your change, and export all the parts out again? Do you open up and edit the intermediate part files that are generated as part of the process? And that question and all the kind of noise that's generated when you export all of those bodies as files and then insert them in assembly, it causes a lot of confusion, just a general kind of tedious workflow. So one of the things that we set out to solve in this our solution to this kind of problem is, how do we make this easy? If you look at the example I was giving you earlier of a concrete bucket, those are really parts, and I will need to insert them into the assembly for hardware, for inserting multiple instances, whatever it is. So they shouldn't be treated as bodies. And we took that as, that's the way design should be. These should be treated as real parts. And what I mean by real parts is they can be inserted directly into the assembly. I can go to the properties. If I go to Workspace Properties, expand out the Part Studio, I can assign a description, a part number, a revision to one of these parts within the Part Studio. So they're not treated any differently than if I had modeled them in their own tab. Right? So each part within your Part Studio is unique. It has its own metadata. It can be inserted into the assembly uniquely, not as part of the overall Part Studio. So you don't have to do anything special to insert just one part of your Part Studio. You don't have to do anything special to insert the entire thing. But again, the key thing with stress is we really wanted it to be important that when you design in a top-down manner in a multi-part Part Studio, that they really are parts from the very beginning, and there's no kind of middle body ground before they go into the assembly. Now, to show you what I mean, I'm just going to create a blank assembly here, and if we go to Insert, as I mentioned before, it's straight into the assembly. Right? So if we go back to our simple graphic here, there is no between step. If you go from a multi-part Part Studio into an assembly, you literally click Insert, and you have your Part Studio there. Now, I can insert the entire Part Studio if I left-click, so all 10 parts, in this case, are inserted at once. But I can also expand out on the Part Studio selection and say, no, I want to insert only the large arm. Right? Or maybe I need to insert 2 instances of the large arm. Right? So we can insert the large arm, and then another instance of the large arm. So you can have multiple instances. You can pick and choose parts that you want to insert into the assembly. They are, again, treated no differently than if you had modeled these in their own tabs. And there's no in-between steps in that process. So again, that was something that I would stress. And the same goes for drawings. You can insert these parts individually into a drawing, or you can insert the entire Part Studio into a drawing, but there's no need to export or import or any of those types of things. All right, so jumping back here real quickly. So just to reiterate our advantages, so I want to go over just a few of our advantages again, and then I'll go over a few cool examples that I have of multi-part Part Studios, kind of showing the power of this scenario. So the big thing with stress, just to reiterate, going back to our examples, is that when you create parts in a multi-part Part Studio, they are parts from the very beginning. They're not bodies that then need to be converted to parts. So you can start assigning metadata right away. You can insert them into the assembly or drawing right away without any kind of management of other files. So no import export step needed to take a multi-part Part Studio and take it into the assembly. But the biggest benefit in general of multi-part part modeling, and one of the things that we've really prided ourselves on, is the fact that you have a really clean way to have one parametric feature list for multiple parts. Right? I think oftentimes when people think of a feature list, they think of generating features for a single part. But in Onshape, one parametric feature list can represent a number of related parts, and that ability is really powerful. And it's something that we've tried to make really, really easy to use. So those are just some of the advantages, the key things that I would stress about our multi-part part modeling versus the multi-body approach of past CAD systems. All right, so a few questions that I've missed, so forgive me. Can you unlink single part and reuse it elsewhere and break references to the original? You can insert as derived. You can create a version as an insert as derived and it will not update. So I believe that will accomplish what you're referring to. It will not update on the fly. At least you'd have to tell it to update. It's not formally unlinking or breaking it. It just only reflects that version, and it will never change. So I hope that answers the question. Would you use this method when using part creation like spur gears, or better to make as separate part studios, and how if it is in the same studio? If I'm designing like a complex relationship between multiple spur gears, maybe, but not if I'm just defining, I just need to input, X amount of spur gears and I just need to drop them into my assembly at random. I don't know that if designing around the spur gear location and all of those details is super critical, then maybe putting those together in a part studio makes sense. But I tend to lean towards those being broken out. In general, I would say if it's just generic hardware that doesn't really have any kind of special design intent purpose controlling it, I would tend to put that in separate part studios. I will say that there's disadvantages to going the other route too. Of putting everything in a single part studio really has performance disadvantages. It makes the feature list kind of chaotic. So there's a fine balance, I would say, where you really want unique and related parts together in a part studio, but not everything. And I know that's a case by case basis. So. But I would say that, hardware, things like that, I would probably put in its own tab. You did not show related model the screw and handle to the arms. A quick explanation. You did not show how you related the modeled the screw and handle to the relation of the arms. In relation to the arms. Forgive me. I believe you're referring to here in the design. This screw in relation to these arms. We can go back and roll through this design in just a bit. It's a fairly straightforward, cut of the pin and extrude off of that. That's then subtracted from this pin later as part of a boolean. You'll see there's the boolean operation. If you stick around, I could walk through this step for step and give a little bit better explanation of all the various features, and not just the first few. All right, so that is what I had planned. I want to wrap things up with just a few cool examples of multi-part part modeling, just showing some of the power of this approach, and where I might, use multi-part part modeling. Now, one great example of this is this pneumatic cylinder, and the reason I like to point this cylinder out is it's an excellent example of a configurable design. And configurations are kind of an aside topic, different topic, but one of the unique things about designing multiple parts in a part studio is you can easily configure them. And if you build things kind of in this top-down manner using a single feature or a single sketch to drive everything, it makes it very easy for you to build a configurable design, because you only have a few places where you change a few values and a large number of parts update. And this is an excellent example of that. We have 9 parts in this pneumatic cylinder, and I can change the bore of the cylinder, for instance, by punching in a different value for my bore in the configuration variable input, and all of the parts update. Right? I can change the stroke of this cylinder, right? And all of the parts will shift to accommodate it. So it's a scenario where we've essentially built 9 parts that are driven by, in this case, 2 key numbers, the bore and the stroke. And, it allows you to build in a very efficient manner. Now, I will say, notice again that I've only modeled what's unique, right? And what's only one instance of that. So the tie rod is an excellent example. you can only see one tie rod in the part studio. Of course, in the finished assembly, you're going to have 4 tie rods, but we did not model that 4 times in the part studio because it's just the same part, quantity 4. And that should be done in the assembly. So another thing to stress again, you really only want unique parts modeled once in the part studio. But again, it's just kind of showing you the power of the workflow. It does take some deliberate design thought, design intent as you're sketching and creating your features. But an excellent example is that cantilever clamp where I showed you a moment ago, where I have one sketch that kind of drives everything. I could build off dozens of parts off of that single sketch, and then control everything from that one place. And configurations is just kind of taking it to that next step for configurable designs, for designs where this makes a lot of sense. But I would argue the two go hand in hand very much, because proper design intent allows you to build configurations in a very fast way. So this is configured in some neat ways. Bore and stroke is something I mentioned, but also there are 4 potential port positions. And one of the cool things you can do with configurations is you can build a list of possible options and then switch between those different options. So, this has a port for the in and out of the hydraulic cylinder, and I can choose whether it's at 0, whether it's at 90, whether it's at 180. I can put that port position wherever I want just by choosing the values in the dropdown. And that just controls a transform feature, which sets a rotation angle. So again, rather simple to set up when you think about it, but really a lot of power once it's set up and controlled. Now, one of the benefits of multi-part part modeling is that it's easy to just drop everything into the assembly when you need to. So let me give you an example of that. Let's delete everything out of this assembly and start fresh here. If I go to Insert and I choose Part Studio, as I mentioned before, you can insert individual pieces of your Part Studio, right? I don't have to export first as files or anything like that. I can just go in and choose the blind cap, for instance. But I can choose also the entire Part Studio. What you'll also notice, this is a bit of an aside for configurations, but you can also punch in configurable values as you insert. So I don't have to open up the cylinder to say, well, I need a 4-inch bore, 13-inch stroke at a 0-degree port position. I click Generate, and it will build that configuration on the fly. I click the Part Studio, and it drops everything in for me. Right? So it makes it a very easy workflow for building your assemblies. Now, it's here that I would do something like a circular pattern, right? And pattern the tie rod 4 times to get my 4 instances. But again, I'm patterning the part in the assembly, not in the Part Studio. Again, I want to stress that because now I have multiple instances of the tie rod. When I go to generate a bill of materials, it will be tie rod quantity 4, which is what I would want. Right, so that's an example of Part Studios, and again, the benefit is going straight into the assembly without any additional steps. I can then pattern parts. I can, do all the things that I need to do at the assembly level, and I don't have to manage all of those, files that are generated. One of the biggest things, excuse me, that I mentioned earlier is when you do this, if you follow the multi-body workflow where you generate a file with a bunch of bodies and then you generate a bunch of files that then are inserted in the assembly, the process of updating becomes much more cumbersome. The question you would ask yourself in some scenarios is, what do I do if I wanted to make a design change? How do I push all of those design changes up through the assembly and so on? And this is where Onshape really shines, because we don't have that intermediate step. If you change a Part Studio, it's going to, of course, update all the parts in the Part Studio, but it'll also automatically update anywhere that was inserted in that document. So there is no, I need to re-export everything again and re-import anything again into the assembly, or update individual. I don't have to worry about any of that stuff because the Part Studio went directly into the assembly. It will update directly as soon as designs change. So again, the key thing that I would stress throughout this webinar is we really tried hard to make this top-down design workflow a first-class workflow that's easy to use, that doesn't involve a lot of kind of workarounds and management of files and so on. So it should just be natural, simple, less headache. And that was the goal. All right, so that is what I had planned. I am going to stick around and answer any questions that you'd like. So if you'd like to stick around and watch me walk through the cantilever clamp bar in a little bit more detail, please feel free to do so. If you have any outstanding questions, please feel free to type them in the questions section there in the GoToWebinar control panel. I will do my best to make sure that all questions are answered before we wrap things up here. But that is what I had planned. One final comment that I had is if you're new to Onshape, if you're interested in learning more about Onshape, learning to use Onshape, definitely check out the Onshape Learning Center. You'll find it at learn.onshape.com. There you'll find self-paced training, instructor-led training, and technical briefings, and lots of great content for learning Onshape. So definitely a valuable resource if you're interested in learning more. So that's what I had planned. I want to say thank you, everyone, for joining. Stick around if you have any other questions, but otherwise, thank you and have a good day.